Okay, a few students had emailed me questions about some of the homework problems, so there's just one I wanted to go over as far as solving trigonometric equations. And this one was page 618, number 36. And we're just solving an equation, and it's 2 sine squared minus 1 equals 0. And we are told to solve this on 0 to 2 pi. Correct? Yes, good. So in this case, we're not looking for the general solution, just the solution on the unit circle. So I want to solve that. And well, again, if we think about this algebraically, ultimately to solve for it, I have to solve for x. In order to solve for x, I have to isolate x. So I do all the exact same algebra that I'm used to isolate x. First, add the 1. 2 sine squared x equals 1. Divide the 2. Sine squared x equals 1/2. Now the problem is, this is squared, and I know I can use an inverse trig function, arcsine, to get the x out of the sine, but that's sine squared. So before I can use my arc trig function, I have to get rid of the square. So I square root both sides. On the left, the square root of sine squared is sine x. On the right, keep in mind here, just like in 171, I'm square rooting a square, so I get the positive and the negative. So I get plus or minus the square root of 1/2, which is plus or minus root 1 over root 2, which is plus or minus 1 over root 2, which we know is plus or minus root 2 over 2. And yes, you can just jump from here to here. I was just writing it out long form to make sure nobody was confused. But now there we go. Sine x equals plus or minus root 2 over 2. Now take the inverse sine of both sides. This just becomes x here. What do I get? All the angles that give me a sine value of root 2 over 2 on the unit circle, which are all the 45-degree angles. So pi over 4, 3 pi over 4, those will be the two positive root 2 over 2's, 5 pi over 4, and 7 pi over 4. Those would be the two negative root 2 over 2's. And again, this was just really quick. It's just one of the problems that people have emailed me about. If there are any other questions, feel free to let me know, and I'll make more videos going through them. Just keep in mind, though, and I mentioned this before in the videos, all the algebra you know from 171 applies here. Solve for x, so isolate x, which means add the constant, divide the coefficient. Oh, I have a square, get rid of the square. All the same tricks. Sometimes we have to solve quadratics by factoring because we use the same algebra from 171. The only difference here really is, from some of the problems that we've seen, occasionally I have to pull out a trigonometric identity. And then at the last step, I generally have to do some inverse trig function to get the angles that I care about. But all things being equal, the algebra actually works the exact same.